channel. Let's look at what physics JAMB class, and our point of focus is going to be speed, velocity, and what and acceleration. So if you are going to write the upcoming JAMB, then you have to pay close attention to this video here, because in this video I want to explain everything about the speed, velocity, and acceleration, and various type of calculation and the ways and pattern you see questions in the exam. So make sure you have to prepare your notebook and your calculator. You have to follow through this class we are doing now. You get. So now, what is speed? Speed is defined as the rate of change of distance with time. Speed is a scalar quantity. Now, same with what the velocity. Velocity is what is the rate of change of displacement with what time. So speed and what and velocity, they are related. Just as speed use what distance, then velocity will use what displacement. Now displacement is what is the distance traveled in what the specific direction. Just but there's no specific what direction. So when we look at speed, average speed cover equals to what? Change in what? In distance. But what? Change in what? In time. I get. So you can say distance is what? X, what? T, which is what? Time. Now distance, the unit is what? Is meter. Right time, the unit is what? Is seconds. So you can say that the average speed, here you can say average speed, average speed now is going to be what? Meter per what? Seconds. Meter per what? Seconds. Meter what? Per seconds. Now, meter, the dimension is what? Is length, L, Y, second, the dimension is what? Is T. So the dimension for what? For the speed is what? This one here. Do you get that? Now when I talk about change distance means what? Final distance minus what? Distance. What? Final time. Final time minus what? Initial what? Initial time. Yes. So average speed is what? No, change distance or change distance. Final distance minus what? Final distance minus what? Initial distance, or what? Final time minus what? Initial what? Time. Do you understand? So we are going to take some quick example for you to understand this thing very well. Let's take some example. Okay, now let's look at what these three set of questions under was speed, right? So pay close attention here. Is that a student walks a distance of 5 kilometers for 17 minutes. Calculate his average speed. So now the question is very easy. It's very easy. So here we are. My distance, the distance covered, distance is what? Is 5 kilometers, right? And the time is what? The time interval here. Time is what? 70 what? Minutes. Do you understand? They're asking of what? The speed, right? They're asking of the speed. Remember, speed equals what? The distance covered over what? Time. But understand that they say it should be what? In meter per second. So here must be in meter. Here must be what? In seconds, right? Now, but here is the stuff here. They gave kilometer instead of meter, and they gave what? Minutes instead of what? Seconds. So it means that I have to convert what? 5 kilometers to what? To meter, and why? 17 minutes to what? To seconds. So how do we do that here? That is where we are going to use what? The conversion factor, the relation between kilometer and what? Meter. Remember, 1 kilometer is equal to 1,000 what? Meter. Is okay. And here, 1 minute equals to what? 60 what? Seconds, right? So this is what you want to put here. So in order to do your conversion here, you going to be times. You put your division sign here. Now, kilometer is already at the top. Kilometer come to the down. Then 1,000 meter will go to the top. So kilometer and kilometer what to go at. Do you understand? So if that's up, we are going to have 5 times 1,000 meter. We're going to be 5 times 10 to the 3 what meter. Why? Because 1,000 is also the same as 10 to the 3. Do you see that? So that is my distance is what 5 exponential what 5 times 10 to the what 3 meter. That is me. Do you understand? Now on the other hand here, now let us say time. Time equals what 70 what minutes, right? 70 what minutes. I know that for every 1 minute I have what 60 what seconds, right? For every 1 minute I have what 60 what seconds. I'm not going to convert it here. It's going to be times. Put your division sign here. Now minute will be identical because 1 minute because it was 60 what seconds. So 60 what seconds here. So minute will be at down. So 1 minute will be at the down. Then 60 seconds will be at the top. Now the main reason is because so minute and minute what we got. So what do I have here? It's going to be 70 times what 60 seconds here. It's going to be what? So which is going to be 17 times what 60. Here I have what 1020 what seconds. This is that. So that is I can easily what substitute what my value is here now. It means I can easily what substitute what my value here is what seconds. Seconds, right? So now my distance is what 5 times 10 to the 3, which also is same as what 5,000, right? Which is what meter over seconds here 1020 seconds. So 5,000 divided by what 1020. Here we have what 4.9 meter per seconds. Can you see that? So it's very easy here. Now there are type of questions you should be expecting what the JAMB examination. You get that? So yeah, distance already is given in kilometers. So you have to convert kilometer to what to meter by multiply by what 1,000, right? Then time was given to me in what in minutes. For you to convert minutes to what to seconds, I have to multiply by what 1,000. So but this is what the way you do your conversion here. You get now. So you have to convert what 17 minutes to what to second by multiply by what 60. Just now, so that's why we multiply by 60. So something our value we have 4.9 meter per what second, which also is saying about 5 meter per what per seconds. Just and so that's what the first one here. So let's look at the second question. Let's look at the second one here. They say that a motorist traveling at 75 km per hour has his eyes shut for 0.4 seconds during a hard sneeze. Calculate the distance covered by him during this time interval. So look at something here. So my speed have already been given to me to be what? Speed have already been given to be what? 75 kilometer per what per hour. Do you understand? Now, and they gave me what my time. Time is what? Time is 0.4 seconds. They ask you what is what the distance covered. Distance covered. Distance. It's okay. So what are you going to do here? Now, remember, distance must be what in meter. It's okay. Distance must be in meter. What you want to know is that distance must be in what in meter. So what you want to do here is to what convert. What you want to do is to convert what this period kilometer per hour to what meter per seconds. It's okay. So this is why I want to teach you of conversion now. You need to understand conversion. Now, if you check very well, you have 75 kilometer per hour, right? Remember, speed, if you look at speed, is what? Distance over time, right? So here we have 75 kilometer over what? 1 hour. Do you see that? Now, here, I have to convert what? Kilometer to what? To meter. And hour to what? To seconds, right? Remember, 1 kilometer equals to 1,000 what meter, right? And for me to convert what for hour to seconds, remember, 1 hour equals to what 60 what minutes, and 1 minute equals to what 60 what seconds. This is that. So this is the conversion we are going to what make use of. Very important here. So that is my speed is going to be equals to what 75 kilometer over what 1 hour here times. So this is where I'm going to do the conversion here. So first of all, let's look at what the distance first. Let's look at what distance. 1 kilometer equals to 1,000 watt meter, right? Now, when you're doing your conversion, you must do it such a way that meter must cancel, unit must cancel out what units. It means that my kilometer is already at the top here. If I should bring some down here, I would have 1 kilometer, then 1,000 watt meter. So that kilometer and kilometer watt will go at. Do you understand? So you need to know how to do this conversion. Then I've converted what? My kilometer to what? To meter here, right? So what we left is what? Is hour now. I want to convert hour to what? I want to convert hour to what? To seconds. I'm going to say times. Yeah, remember 1 hour equals what? 60 what minutes, right? My hour is already done. So hour is going to be at, so I want to have 1 hour here. 1 what? 1 hour. Then I want to have what? 60 what minutes. 60 what minutes. So that hour will cancel out hour here. I'm going to say times. Remember, 1 minute equals to what? 60 what seconds, right? So minutes is already done. So 1 minute you go to the top, then 60 seconds you go to the down. So minutes will cancel out minutes here. So what do I have left? So this is what I have left here: 75 times 1,000 meter times what? 75 times 1,000 meter times 1. So you can leave it here over 60 times 60 what seconds. This is that. So what am I going to have here? 75,000 meter over what? 60 times 60. Here we have 3,600 what seconds here. So if you should do division here, this by this. Here I have 7500 divided by 360. 3600. Yeah, and now about 2.083 meter per watt second. So this is not what my speed. Do you understand? So if now the short term here is that if you are converting kilometer per hour, if you are converting kilometer per hour to what meter per second, you have to what multiply by what 1,000 and divide by what 3,600. Do you understand? So what you want to do here, if you are converting now, look at something here. Whenever you are converting kilometer per hour to meter per seconds, multiply the value by 1,000 and divide by what 3,600. Do you understand? You get your what the value here. If you don't want to go through this process, so now if you don't want to go through this process here, but this is what the normal conversion process. If you don't want to go through this process of conversion here, now whenever you are converting from kilometer per hour to meter per seconds, multiply the value by what 1,000 and divide by what 3,600. So you have to get what meter per seconds. It means that my speed, I can say what speed is equal to what my speed is now going to be what 2.083 meter per watt seconds. That is it, meter per watt seconds, right? Now remember, what are we looking for? We are looking for what? Distance. Remember, speed equals to what? Distance in meter over what? Time in what? In seconds, right? So if I should make distance in formula here, because multiply distance equals to what? Speed times time, right? So my speed is what? 2.083 meter per seconds times my time is what? 0.4 seconds here, right? So 2.083 times 0.4, yeah, what? 0.833 what? 2 what? Meter. That is what? That is the answer here. So that is what for number what? 2, right? Please, if you are following this class here, please kindly give this video a like and comment at the comment section that if this video is about helpful. It goes a long way to tell the YouTube algorithm so I can promote this video to other persons watching, look for this kind of what content, right? So let's look at what question 3. Look at what question. Okay, now look at this one here. They say that a bird flew at 12 meter per second for 30 seconds, 15 meter per second for what? 4 seconds, and 25 meter per second for what? 6 seconds. Calculate the bird average speed. calculate what the bed average speed. So here we have speed, the first speed. So remember, they say remember average speed because what distance over what time. I there. So if I want to get my average speed, then I need to what look for the distance because here we have speed 1 time 1, speed 2 time 2, speed 3 time 3. Do you understand? So that is if I want to look for the distance here, I have to look for what the total what distance. I there. So total distance, total distance, total what distance is going to be what d1 plus d2 plus d3 is okay. So here we're going to have total time because you're talking about average speed. Calculate calculate what the bed average speed. Do you understand? So that is the average speed is going to be what total distance covered by the bed and total time covered by what by the bed. Do you understand? So here we have total time going to be what t1 plus t2 plus what t3 is okay. So how do you get my d1? Remember, what about speed? Speed because of what distance about over time, right? So if you want make sure it's a formula here, that is distance is equal to what speed times what time is okay. So that is I want to have what my d1, that is distance 1. Distance 1 is going to be speed 1 times what time 1. Distance 2 is going to be what speed 2 times what time 2. Distance 3 is going to be what speed 3 times what time 3. Do you understand? So you can now have what d1 equals to what what is my speed? My speed is what 12 meter per second and my time is what 3 what seconds. So going to be 12 meter per second times 3 seconds, right? D2, that is distance 2, second distance traveled by the bed is going to be what 15 meter per second times 4 seconds, right? Then D3 is what 25 meter per second times what times 6 seconds. So what do you do here to bring out your calculator? So 12 times 3 is what is 36 what meter, right? Because this time is going to be meter. Then 15 times 4, here we have what 60 meter. Then 25 times 6, here we have what 150 what meter. Do you see that? You do something. So that is my total distance. Now if I say I should calculate my total distance, right? Total distance, you have to sum it together. So it's going to be 36 meter plus what 60 meter plus what 150 what meter, right? So up here it's going to be 36 plus 60 plus 150, right? So you have 246 watt meter. Now let's look at what total time. Total time, let's say total time is going to be what t1 plus t2 plus what t3, right? My t1 is what 3 seconds. My t2 is what 4 seconds. My t3 is what 6 seconds here. When you add everything together, here we have 3 plus 4 plus 6, here we have what 30 what seconds here, right? Now that's my total distance is what 246 meter. My total time is what 13 what seconds, right? So remember my average speed here, like you say average speed here. So average speed is equal to what the total time, right? My total time is what? 246 what meter, right? 246 meter over my total time is what? Is 13 what seconds here. So what we want to do here is to what? Divide them. So 246 divided by what? 13. Here we have 18.9 meter per seconds. We approximate going to be what? 19 meter per what seconds. That is the what answer. So with this now we are done with what? We are done with speed. So now let's move to what? Acceleration. So let's look at what rectilinear acceleration. So you have to take some important note when it comes to what rectilinear acceleration for proper what understanding. The term rectilinear acceleration means the rate of increase of velocity along a straight path line in unit time. When the velocity of an object changes, it could be said to accelerate or decelerate. Acceleration is defined as the increasing rate of change of velocity with time. The acceleration of a body is said to be uniform or constant when the velocity is increasing by equal amounts in equal time, in equal interval of time. You get? So now we're talking about acceleration. Acceleration is equal to what? Change in what? Velocity, right? Change in velocity, change in what? Velocity over what? Change in what? In time. Just and change velocity over what? Change in time. And velocity equals velocity, remember velocity is equal to what? Displacement over what? Time, right? Change displacement over what? Change time, right? Displacement is what? Meter, time is what? Seconds. So the unit of velocity is what? Meter per what? Seconds. And the unit of time is what? Is seconds. So if you want to get the unit of acceleration, remember acceleration equals to what? Meter per what? Seconds over what? Seconds. Yeah, right? Now this is also the same thing as what? Meter per seconds divided by what? Second. That is the meaning, right? Because this division here. So now whenever I have something like this, you also see that meter over what? Seconds divided by what? Seconds. So if you change that to times, what are you going to get? You're going to be meter over what? Seconds times 1 over what? Seconds, right? So it's going to be meter over what? Square second square. So the unit of acceleration is what? Meter per second what? Square. Very important. Meter per what? Second what? Square. This is what you need to understand there. So if I talk about acceleration, I say what? Change velocity over what? Change time. What does it mean? It means that final velocity minus what? Initial what? Velocity over what? Final time minus what? Initial what? Initial time. That is meaning final velocity minus what? Initial velocity over what? Final time minus what? Initial what? Time. Just and this is very, very important here. So the next one I want to look at is the equation of what? Of motion. Now before you can solve anything, you need to understand what's called equation of what? Motion in what? Make us what? Acceleration. And we have about 4 of them here, which we are going to look at. So here we have what? 4 equations. 4 equations of what? Motion. So now, for you to solve any questions under what? Acceleration or equation of motion, these are 4 equations you need to what? Take note of. So depending on the question, then you have to apply the formula in solving that what problem. Just that. So let's look at what the 4 equations of motion. The first one here is what? V equals to U plus AT. Now let me say this here. There are ways in which what these things are being derived. You get, there are ways in which what these things are what this equation are what be derived. So I don't want to go into the derivation process. That is what I'm just giving to you. In your exam, you'll not be asked to derive anything. You always look at the question and see the question you can use in what exactly what that question. Do you understand? So v equals to u plus what at, which we are going to define as we move on. Number two, x equals to ut plus half at squared. That is what second equation of motion. X equals to ut plus half at squared. I'm going to define all these things to you. 3 is what? V squared equals to what? U squared plus 2ax. Very important equation of motion. You see how we are going to use this square equation here to tackle problem. Then the number four is x equals to what? U plus v t over what? 2. Very important here. So now let's start defining everything here. V is what? Is the final what? Velocity, meter per seconds. U is what? Initial what? Velocity. Initial what? Velocity, meter per what? Seconds, right? A is what? Acceleration. Acceleration is what? Meter per second what? Square. X is what? Is distance traveled. Distance what? Traveled, which is what? In meter. Then t is what? Is time, right? Which is what? Seconds. Do you understand? So these are what the equations of what? Of motion. But there are some important notes into what take note of. There are some things into what take note when you are using these formulas in what solving problem here. These are things you must consider when you are solving equations of what? Of motion. So let's look at them. The first one, number one, when an object move or accelerate from rest, its initial velocity u is what? 0. Number two, when a body comes to rest or stop, its final velocity is 0. Number three, when a body velocity is constant or not changing, its acceleration is what? Is 0. Then number four, when an object accelerates uniformly, the acceleration is positive. The last thing you want to take note here is that when an object decelerates uniformly, the acceleration a is negative. So these are the 5 things you know what take note when you are solving problem under equations of what? Of motion. So let's take the first question. Okay, now so let's look at what the first questions on this acceleration is. That a particle accelerates uniformly from rest at 6.0 meter per second for 8 seconds and decelerates uniformly to rest in the next 5 seconds. Determine the magnitude of the deceleration. Very important here. This one is 2 questions in one. Therefore, you have to calculate what the final velocity. Then the next you want to calculate is the acceleration, what we call deceleration. We're going to decrease. So let's look at the question here. Solution. Very important here. This is that a particle accelerates from rest. So remember, when a body moves from rest, the initial velocity is what? Is 0 because it accelerates from rest, right? So the acceleration here is what? 6.0 meter per second, right? Now the time, the t is what? 8 seconds. 8 what? Seconds. Let's say what and accelerates uniformly to rest in the next 5 seconds. Determine the magnitude of the deceleration here. So at first you want to calculate what the magnitude of the deceleration. But therefore, let's look for the final velocity. Look at what the final velocity here. Here we have the initial velocity, right? The acceleration, the time, and what we are looking for the final velocity here. So we are going to use v equals to what? U plus a t, right? So let's calculate from here. So which is going to be v equals to what? My u is what? 0 plus a is what? 6.0 times 8 here. We're going to give what? V equals to 6.0 times 8. 6.0 times 8 is what? 48 48 meter per what per second. So now if you look at the question here, it's that a particle accelerates uniformly from rest. That's why u is what 0, and the acceleration was 6.0 meter per second square, right? The time is this, and decelerate, then decelerate. Remember, this is what my final velocity at the first moment here. So when it's decelerating here, this guy is now going to be what my initial velocity. So yeah, you want to calculate what deceleration here, this acceleration here. So here going to be what my v, going to be what my initial. So this one is going to turn to what? This guy is going to turn to what my. This is going to turn to what? To my initial what velocity here. So going to be what? 48 meter per second, right? So let's say that I'm accelerating formally to rest. Remember, when the body moves to rest, is my final velocity is what? Is 0. Understand this here. When a body comes to rest, the final velocity is what? Is 0. You get? So v is now going to be what? 0. The time is what? T is going to be what? T is going to be what? 5 what seconds. This is that. So that means we are going to use this one here because the acceleration is going to be deceleration, because it's decelerating, that is going to decrease, right? So v equals to u plus at. So the goal here is to make a the formula here. So going to be v minus u equals to what? At. Now make it a the formula here. Going to be a equals to u v minus u over what? T. Can you see that? So what are we going to do here? So let's substitute what our values. Let's substitute our values. So let me write this place out. So what are you going to get here? So going to be a equals to my initial velocity, my final velocity now, because it moved, it accelerates to rest, right? 0 minus my initial now is that what? 48 over my time is what? 8. My time is what? 5 what seconds here. So what will be the answer? Going to be minus 48 over what? 5 equals to what? Minus 9.6 meter per second square. Now here's the thing here. Please look up where it's in here. Now, so my acceleration here is going to be a equals to what? 9.6 meter per second square. Is okay. So you don't need to put what negative sign here, because they say it's already deceleration. So whenever you hear deceleration, that is what? The acceleration is what? Is negative. Or whenever you hear acceleration, that is the acceleration is what? Is positive. The value is what? Positive here. So they say deceleration is what? 9.8 meter per second square. So they don't want to put the minus here. Do you understand? So that is for the what? For the first question. Okay, now let's move to the next thing. Question 2. A body accelerates from rest at the rate of 3 meters per second for 8 seconds. Calculate the distance covered by the body during the acceleration. So solution. So now before we pick the formulas to use, therefore let's write out our parameters. A body accelerates uniformly from rest. So basically they say accelerates uniformly from rest. From rest, my initial velocity is what? 0. So u equals to what? 0, right? That is the initial velocity is what? 0. The rate, the acceleration here is what? Is 3 meter per second square. Now the time is what? 8 what? Seconds. Can you see that? They say calculate distance. So we are calculating what? X. So of course there's no distance, so you cannot use one here. We can use this guy. X equals to ut plus half at square. I look at distance. So you are using what? The second equation of motion. X equals to ut plus half at square, right? So u is what? 0 here. So going to be x equals to 0 times t. My t is what? Is 8 plus half times my a is what? Is 3 times my time is what? 8 what? 8 square. So this is going to be 0, right? So going to be x equals to 0. So can you ignore it? 1 over 2 times 8 square 8 squared times 3 divided by 2. There we have what? So it's going to be, so when you do your calculation, you're going to be 96 what meter. That is what is the answer. So we are going to end this video today. Now we are going to end this video here now. Now more questions on that what equation of motion will be coming up as we move on. Do you understand? So if you're not subscribed to the channel, please kindly subscribe to the channel. Then turn on the notification bell icon so that whenever I upload a new video, you'll be notified. Do you understand? Thanks for watching. See you in my next video.